All right, we're going to divide complex numbers here. Camera so you can see it. All right. Dividing complex numbers, specifically something like this. All right. There's a tendency to not want a square root on the bottom of a fraction. And I, if you'll remember, represents the square root of -1. So our goal when we divide complex numbers is really just to get that I off the bottom. We don't care about the top. It's kind of sort of collateral damage, you could say. We're not concerned about it. It does get caught up in the action though. So what we want to do is multiply top and bottom by the conjugate of the bottom. The conjugate, in general, a plus bi is a minus bi. That is, you just change the sign in the middle. So 3 plus 2i is what I'm going to multiply by. Notice that I'm going to multiply the top also by 3 plus 2i. It's a common mistake for people to comprehend that the conjugate gets involved, but then try to introduce the conjugate at the top. But remember, we don't care about the top. But in math, you can't just do things for free. If you multiply the bottom by 3 plus 2i, you have to get some sort of compensation. That compensation is also to multiply the top by 3 plus 2i. In this case, you're actually multiplying by something whose value is 1, okay? Because something divided by itself is 1. But when you multiply by 1, the value doesn't change. So we're looking for an equivalent expression. The word equivalent in math means of equal value but of different appearance. So we're trying to fix this bottom up, and the top just sort of gets called along in the action. Well, let's actually perform the operation here. Remember, when you multiply two binomials, that's going to require 4 products. 7 times 3 is 21. 7 times 2i is 14i. 6i times 3 is 18i. 6i times 2i, well, that's 12i squared. On the bottom, with the conjugates, there is a shortcut. I'm not going to use it yet, but there is a quicker way. 3 times 3 is 9. 3 times 2i is 6i. Negative 2i times 3, that's negative 6i. And negative 2i times positive 2i, that's negative 4i squared. I'll mention the shortcut just here in a minute. Notice that we have 2i squared, and one of the first things you want to know about working with complex numbers is that I squared is equivalent to -1. You never want to leave I raised to any power. And there's a separate video, separate lesson to discuss what the powers of I simplify down to. And we do tend to like I, which represents the square root of -1, but we'd rather leave it I. So we like I. 14 plus 18 is 32. We don't, however, like I squared. It becomes -1. And on the bottom, the inside and outside cancel. That is by design. Conjugates are designed intentionally to eliminate the middle two terms. I squared sort of eliminates itself by becoming -1. And when I say eliminates itself, it eliminates the complex part of that, or the imaginary part of that, I should say. The number on the bottom will become a real number. Now, some people don't write -1. They know that if you multiply by -1, then all that's going to accomplish is a change of sign. So many people will avoid that. So I'm going to say 21 minus 12 here. That would be 9 plus 32i. 9 plus 4, remember negative times negative makes positive. That's 13. Sometimes you will see the answer left this way, but there's a tendency with complex numbers to fully separate the real part and complex part into separate terms. So I'm gonna do that here, 9/13 plus 32/13 I. So I did a couple things there. I separated into two fractions. If you have this set up where you're adding over a single number, you can separate it into two fractions if you'd like. Also the I, which appears to be on top here, I did slide over to the side, which is equivalent to being on top. And this puts it in that form A plus BI, the real part being 9/3, the imaginary part being 32/3. I said thirds, 9/13, and the imaginary part being 32/13 I. But that would be correct. And just a quick multiplication, or division rather, of imaginary numbers.